Hi, welcome to Raw Math. Today I'm doing a series of videos on rational expressions and equations. And in this video what I'm doing is I'm looking at the final fraction, which you would get after adding, subtracting, multiplying, dividing, solving, whatever. And then I'm finding the domain, it's important for solving, and I'm reducing, because whenever you have an answer that's a fraction, your last step needs to be reducing. Now, number 3 is a bear of a problem. It has a lot going on. I need to factor first, and since I want to start with the domain, I'm going to actually factor the denominator. Out of the denominator, now a 2 comes out of all 4 terms, but I find that when you have a greatest common factor like 2, it isn't often worked through first. So even though you can take a 2 out right away and make everything a little simpler, I'm going to do this how most students do it. And I'll tell you why at the end. I'm going to take a 2d squared out of the first terms and a negative 2 out of the second, so that I have 2d squared times 5d minus 3, and then a negative 2 times 5d minus 3, so that I have 5d minus 3 times 2d squared minus 2. So the point of factoring, it's really prime factorization of a polynomial. If I was doing prime factorization of 20 and I had 2 and 10, I wouldn't be done, because that 10 can still be factored down to get to all of my primes. I would have to go further to 2 and 5. Well, that's what's happening now. This 5 minus 3 is prime. We're done with this binomial. This is far from being done. First of all, I can take a 2 out of both terms, and I'm going to write the 2 out front because multiplication is you're allowed to multiply in any order. So I'm going to bring the 2 out front. 2 times 5d minus 3 times d squared minus 1. And once again, we can go another level because we have a difference of 2 squares. 2 times 5d minus 3, d plus 1, d minus 1. Okay, so for my domain, let's see, this 5d minus 3 cannot be 0, so 5d cannot be 3, d cannot be 3/5. For these two, it's a little bit simpler. This is 0 when d is negative 1. This is 0 when d is 1. That's my domain. And I'm done with it. I'm not going to go to any other notation for domain for now. Now that I have my domain and my denominator factored, I now focus on the numerator. My numerator is 5d cubed minus 3d, that should be a squared, minus 20d plus 12. If it were a cube, this actually wouldn't be factorable by any basic factoring methods. Okay, out of the first 2, I'll pull a d squared. Out of the second 2, I'll pull a negative 4. D squared times 5d minus 3 minus 4 times 5d minus 3. We have 5d minus 3 times d squared minus 4. And once again, we have the situation where we are not completely done factoring. We need to take it one more step because we have this difference of 2 squares, so that we have 5d minus 3 times d plus 2, d minus 2. That's my numerator. I'll now bring my denominator back down. My denominator is 2 times 5d minus 3, d plus 1, d minus 1. And we only have one bit that can reduce, that's fine. So my final answer becomes d plus 2, d minus 2. And now the parentheses are essential because there's 2 things being multiplied together. I could multiply it back out to d squared minus 4, but I usually don't do more work than is necessary, because if you do extra work and you do something wrong, you could lose points that you wouldn't have to lose. So you have to find out if your instructor is expecting you to multiply out your binomials. I personally do not. 2 times d plus 1, d minus 1. Of course, multiplying it out is pretty simple because we have all the answers here. D squared minus 4, 2d squared minus 2. But I'm going to leave it factored because then I can visually confirm I am done. Now, number 4 is a fun problem. It's a fun problem because it's m to the 4th and m squared. You can still do any of your trinomial tricks as long as the exponents in your first term are twice that of your second and there are no variables in the last. Double, single, 0. If you have a double, single, 0, you can factor. So 2 numbers that, well, before we factor that, let's look at this denominator, m squared plus 4. When we look for the domain, we try to find out when the denominator is going to be 0. Well, m squared plus 4 is going to be 0 when m squared equals a negative 4. Well, m squared has to be positive. A squared number has to be positive. So a positive can never be a negative. Another way to look at this is if we graph it, and I have some videos on how to graph these. If we graphed this, we have a parabola, a smiley face, that crosses at 0, 4 and points up, which means we never get to the x-axis. And when we're factoring and solving, we're asking, when does this equation cross the x-axis? What happens when y equals 0? So solving is looking for the x-intercepts. So now we have 2 reasons why there is no 0 possible. So my domain is going to be all real. Now, I usually do interval notation here. You can also use the words all real values of m. And we say real because if it was imaginary, we could make it negative. You could also do double bar r. These are the 3 common ways of writing all real values: interval notation, verbage notation, and set notation. All right, just because the domain is all real, this would happen if it was just 4 as well. If you just have a constant, you can't make a constant of 0. You can only have a restricted domain if your denominator can vary down to a 0. So you have to have variables. All right, to factor this, 2 numbers that multiply to 36 and add up to 13 are 4 and 9. So we have m squared plus 4 times m squared plus 9 all over m squared plus 4. Because these cancel, we can write our answer outside of a fraction. You could put it over 1, that would be fine. I usually leave my answer as is. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.